All right, so we were supposed to have a function here for remove worst, right? This guy. So this guy would take in a number of rolls to remove, and so the idea would be after you've rolled your dice. After you've rolled the dice, here's our roll that generated all the rolls, right? So it showed us the recent sum, so the total of adding all those things together. It also showed us the collection of those rolls. When we do remove worst, it should go and find the two smallest rolls in here, remove them, and then go through and remove or update recent sum. That make sense? All right, so here's this guy. All right, so first thing we need to do is we need to identify the position of the two smallest rolls. A couple different ways we could accomplish this. What's one way we could do this? Go ahead.
Sort the list and then pull off the first few indexes.
Okay, certainly do that. You can sort the list and just delete or remove bucket 0, bucket 1.
Mm-hmm.
That'd be pretty good one. All right. What's another way?
You compare values to the list. So like you assign the first value as being the lowest, and you compare that with the rest of the list. And if it's lower, then you swap it out for that one. Then you can take it off.
Okay, so you're kind of doing a sort, but rather than worrying about the whole thing being sorted, you're only bringing the small values to the first, 2 buckets? Because we're supposed to find or did you do it 2 separate times? You're supposed to remove, in the example, we're supposed to remove the number of rolls to remove. So this could be 2, this could be 5, this could be whatever.
Yeah, so it's not super efficient, but I have a loop looking through that many times, a loop going that many times to remove. Then I have it looking through
Finding the smallest and replacing a thing in the front.
Yeah.
So at the end of each run through your loop, bucket 0 is the next smallest. Is the smallest thing in that collection, and then you're removing it that time, and then you're spinning through and doing it again, depending on number of rolls to remove number of times.
Almost. I'm just removing the value that's lowest. So like I'm looking through and I'm just pulling up.
So are you swapping it, or you're just keeping track of where it was found?
Keeping track of where it was found, and then I'm using the remove function to remove the lowest value, so that it'll just pull out the first instance of that lowest value.
Okay. So let's implement a couple of these things, and then we'll look for other ones here. So first one might be, so we can make the assumption that number of rolls to remove is smaller than the total number of elements in there. I think that's a reasonable assumption. All right, so the first thing you did is you sorted it, right?
Yeah.
So you said self.recent rolls dot sort.
I just imported insertion sort.
Okay, that's fine, but this will sort it, right? One way or another, this will get it sorted. All right, so now I know I have my smallest values first, my largest value second. I want to go through and I want to remove elements from bucket 0 of my list. Okay, how many elements am I going to remove? For I in range 0 to number of rolls to remove. What am I going to do? I'm going to say self dot recent rolls dot is it pop?
Pop at index 0.
Pop 0.
Yeah.
All right. And then the last thing to do is to recalculate your sum.
Yeah.
All right. So we'll say
Save the pop in variable.
we could do that actually. We could do it as we're going, right?
Yeah.
So we could say here's the val we just popped, and say self dot recent sum minus equals val. That'll peel it off of our. If we just removed a 3, we'll subtract 3 from our sum because now it's no longer in the list. All right, so this is one implementation of remove worst. So if we check this guy, we'll say remove worst And this is going to be for our, actually I'm going to leave this here like that. So I'm going to say dice collection dot remove worst. This guy takes a number of elements to remove, so I'll remove 2 in our example here. And then I'll go ahead and print out our recent rolls and recent sum. We will notice that recent rolls will now be a sorted value since it wasn't necessarily sorted initially. We could have said we're always going to store it sorted and then always sort it at the end of our rolls, and I'll show you how we could have done that, just moving one line from one place to another. All right, so we're on desktop, right? All right, so our original roll was 2190. Here's all of our rolls. Now after removing the worst 2, we're at 2188. We removed a couple of 1s. So this is our rolls with 2 rolls missing from in here because we removed 2. If instead I wanted to remove,
Which 2 did you remove? 'Cause I kind of.
we removed 2 1s. We sorted it, we removed the first 2 1s that were in our list because we popped from bucket 0. So there would have been 2 more 1s at the very beginning here. The way we solved this is we said, make sure all of our rolls are in order. So that means all the 1s would come first, and all the 2s, and all the 3s, and all the 4s. And then we went through however many elements we were going to remove, and we removed those from the very beginning. So we'll remove the smallest value first. If I say I want to remove more, let's say I wanted to remove 100 of these. That should get us past the 1s probably. We should now see a more drastic drop in our sum. So sum was at 2095. Now it's at 1551. And notice that our smallest roll currently in our collection is an 11 for our D20s. So we removed all of the 1 through 10s. And probably a few 11s. All right, so that's one possible solution. Probably a pretty good solution. If we always wanted to see our rolls in order, one thing we could do is we could take this line and just assume that our rolls are always sorted. So after we roll, at the very end, go ahead and sort our recent rolls, just so our rolls are always visually sorted from smallest to largest. So now when we do this again, notice that we have all our values sorted originally with our sum, and then our values still sorted with our sum, so it's always in order, just by deciding when we were going to sort. Okay, so that's one version of remove worst. Okay. Is there a shortcut in here for, can I do, will this do it? Nope. I can't comment a bunch of lines at once in this?
You should be able to with
Command Shift this.
I don't know what it is on that.
What was it on PC?
It's control //
Oh, so it's probably Command // There we go. So on a Mac, it's Command / instead of Control /. Okay, so here we'll just say solution 1 is that guy. So now we're going to create a solution 2. So let's do your solution for solution 2. Let's go ahead and assume our values were not sorted, because that actually makes solution 2 very much like solution 1. So I'll throw that back down here. All right, so solution 2, we have our unsorted list of rolls. So what he did is he went through number of rolls to remove number of times. So he did something some number of times. Each time what he did is he figured out what is the smallest value here. What's the position of the smallest value in my list? At the end of going through every element in the list, he knew the position of it. He removed that position. Right? And then went and did it again. over and over and over again. Okay, so we're going to have our loop for I in range from 0 to number of rolls to remove. So that's how many times we're going to remove something. Now, to remove something, we need to go through, we need to find the element in our self.recent rolls that is the smallest, the position of that element. All right, so I'm going to go ahead, we're going to say cur pos is equal to 1. Cur min is equal to self dot, is it recent rolls at bucket 0. So we're going to go ahead and preserve the value that's at bucket 0 and assume that's my smallest. And I'm going to start my hunt at bucket 1.
Okay.
So I'm going to say for j in range, I can't use I again because I'm already in a loop that's using I. So j in range from cur pos actually let's just do cur min pos. I'll start that off at 0 and we'll just give myself another value here. So as far as I'm concerned right now, the smallest value was found at position 0. All right. So then we're going to say for j in range from 1, because I've already dealt with bucket 0, all the way up to the length of self.recent rolls. So this is going to go through every element in recent rolls, and each time through I want to ask a question. I want to know, is the guy I'm currently looking at smaller than my current smallest? So if self.recent rolls at bucket j, if that guy is actually smaller than my cur min, then I have a new winner. So I'll say cur min is equal to self.recent rolls at bucket j, and cur min pos is equal to j. I've selected a new winner. If I get to bucket 7 and I find a new smallest value, I'll say, the winner is no longer at bucket 0. My winner is now at bucket 7, and the value is whatever was there. Okay, so each time through, I'm keeping track of what that minimum value is in my list. When this inner for loop is done, I've gone through every element of my list. Cur min pos should point at the guy that is the smallest in the list. And cur min should be the value. Okay, so I'll go ahead and I'll say self.recent rolls dot pop. I'm popping a position. The position is cur min pos. That's the position I'm popping. And I'll say self.recent sum minus equal cur min. That's my smallest value. All right, I'm going to do I'm going to do that whole logic, number of rolls to remove number of times. Okay. So let's test this. I'm currently removing 100. That's fine. So let's run this. So there's my original 2254. Here's all my rolls, not sorted at all. Then here's my new sum, 1646, after removing 100 of the smallest things. Notice these guys are still not sorted, but I do have a lot of small numbers not there anymore, right? So smallest number I see a 12, I see an 11. I don't see any 10, so looks like I removed a pretty similar type thing, right? All right, so the second approach, a lot less efficient, but ran instantly, right? From our perspective, ran the same speed as the other one ran. This was a little harder to implement. Okay. Any other solutions?
Oh, you
Which of these do we like better? They're both kind of difficult in their own ways, right? This one up here required you to come up with a problem of, come up with a solution of saying, it would be beneficial to have my data sorted first. Then it was an easy solution after that, right? After you knew you had to sort it. This one down here, so that complexity was knowing you had to sort it. This one down here, its complexity is a loop inside of a loop, right? Now, when you think about what these loops are doing, this first loop says, I'm removing number of roles to remove number of things. That's what I'm doing. I'm doing something that many times. This inner loop, this guy's job is, I want to go through every element in recent roles and find the smallest. The one smallest element in there. Okay, that's what that inner loop does. But typically for beginning programmers, when you start getting 2 loops in there, or even, hey, go deeper, go 3 loops, things start getting a little bit more hit and miss, right? Because that becomes an intimidating thing for us. All right, so both of these in the big scheme of things are relatively easy solutions. One other thing that happens when you, as a beginning programmer, assuming you found the sort thing, this is a lot easier to conceptualize of because it's shorter. Beginning programmers typically start getting fairly intimidated as soon as the number of lines goes larger than 1. Right? As soon as we're at like 2 lines, things start going. It's like, well, whoa, wait a minute. We like the whole fill in the blank thing. That was hard enough. But now what is this? This is 53 to 61. That's a bunch of lines. What happens next? We write an operating system? So,
That takes 60 lines.
60. That's a 60-line thing. Yeah, the good news is that when you're, well, actually this will happen probably next semester, you'll be writing programs with hundreds of lines. Doesn't that just sound exciting? I mean, now we're right back to the excitement and the easiness of Mergesort.
Doing 100 lines of code. How long was Mergesort? That was longer, wasn't it?
No, Mergesort wasn't substantially longer than this. We wrote it in a pretty blown out way. So maybe it was twice as long as this, just because we wrote it across 2 functions.
Yeah.
Mergesort's complexity is built into the recursive nature of it and splitting the stuff. So, so complexity moves for us, right? Mm-hmm. The logic of this one is a pretty straightforward human logic type thing. You want me to remove 7 things? Fine. I need to find the 7 smallest things on my list. So what's the smallest thing in here? This guy, remove it. What's the next smallest thing in this? This guy, remove it. So on and so forth. That's a very human approach to the problem, right? You know, if you were asked to remove, you had a bunch of numbers, of maybe playing cards spread out in front of you. And they said remove the, using blackjack rules or something like that, remove the smallest 7 values or something like that. You would go through and search it, right? Now, if somebody said remove the smallest 30, then maybe you decide, okay, I'm going to put these in order first. That might make my life easier, because then you could just flip through and get through 30 of them and throw them away because they were in order and those are your smallest. But it's a very human approach to this. And we don't think of this as being all that difficult in real life. We just think of it as being tedious, right? So in a real life solution to a problem, if we flag something as being tedious, that probably means it's relatively inefficient for a computer to do. But that's okay, because computers are really fast and they're made to do our tedious tasks. That's why we keep them around, right? So we don't have to do them. So this guy up here has some complexity hidden within it, right? Somebody had to write that sort function. So somebody, that 1 line of code that we wrote, behind the scenes has a bunch of lines of code that do the magical sort. Mm-hmm. But from our perspective, we just push a button and it's boom, sorted. Which we like, as long as we can appreciate what's behind the scenes there. And we've been able to appreciate it twice, 1.5 times. The one time that worked for most of you, and the one time that worked for very few of you. All right. Questions about this? Any other versions of the solution you want me to write?
So you post on Slack that we cannot use him. So I basically define him and use it to sort.
Yeah, I mean that's so effectively what we did here. So let's write your version of this. So you wrote a function up here. You could have put it inside the object if you wanted to, or you could have made it outside the object because you might have said maybe min doesn't make sense for our dice collection. So maybe we just define a function up here, define min to take a list as a parameter. And inside here, we're going to go through every element in the list and find the smallest value, right? That's what that guy's job is. So we're going to take, where's my remove worst? We're going to take that code right there. We're going to bring it up here. And we're going to say list instead of self.recent roles. And this guy will return. Probably we need it to return cur min pos if we're going to have it give us the position for min, because we want to know where is the smallest value. Where the min built in, I think, gives you the smallest value, right? Like the min that's built into the language will say, oh, the smallest value is 1. Doesn't tell you where it lives. In our case, we might want to know where it lives so we can remove it ourselves. Otherwise, we can use just remove the first occurrence of something.
Yes.
Is that what remove does? All right, so we could then remove or return cur min, which is the smallest value that's in there. So now this guy right here effectively does the identical logic that was in our inner loop, right? We've just yanked it out and put it inside of a function that we can call. So then what we would do down here is we would say cur min is equal to the minimum value in self.recent roles. Then we'll say self.recent roles remove cur min. Then we'll say self.recent sum minus equals cur min. So that's the new solution for that, which is effectively the identical code we had there a few minutes ago. We just took that inner loop and called it a function. Go ahead.
Isn't that using the built-in min?
It is using the built-in. Actually, that's a good question. I think since we wrote our own, this will not use the built-in min. Because it'll find our version of it first.
Because doesn't the built-in one you have to do dot min, not, or I don't know how min works.
Well, here, we can find out real quick.
We can name it differently.
Okay. Well, not name it differently. It'll definitely call it differently. But so let's get a scoping thing here. Let's just make sure this guy works first. All right. So seems to do what we wanted it to do. So now what I'm going to do is I'm going to say I'm going to always see if I try to remove something that's not there. Do we get an error?
There's something that's not there.
Returns
Remove will return -1 if we try to get something that's not there. Because what I was going to do is I could say, I could return -1 here, then we'll try to remove a -1 from our list. It won't find it. Is that going to throw us an error? Let's see if that throws us an error. So then we'll know we're calling our version of min here, right? Because we're always trying to remove a -1 from our list, and our sum should not change then.
Hey.
Okay. So, I mean, it's calling our version of it. So it's the most local version, even though it gave us a crash value. Yeah, so because we happen to name a more local function here called min, it found ours. And that's actually related. Let me open up a Keynote here. to our variable truth. All variables resolve to their most local definition. Same thing's true of functions. The most local definition of our min function is the one we just wrote, not the one that's built into Python. All right, so why did I choose to write my min function outside of my dice collection instead of as a function of dice collection?
I wrote it inside a class, and I got so much trouble with it because, like, the way you pass, like, I don't know, like the way you call the name of it is not passing.
Okay, well, so let's just move it inside the class just to show that example. So I'll delete it from there. And then I'll just add it right before add dice. Right there. Technically, this guy doesn't need to know about the list because he already knows about it. But let's just call it with the list right now. So now when I call it, I'm going to call self.min, passing it my recent rolls. So now that, because now this is a function that belongs to this particular instance of dice collection. So this will have the same.
We need to,
Oh, does it still return -1?
we need to add self to the parameters.
Well, I shouldn't have to. I'm passing it the parameter there, which is our list that is our recent
We're gonna
rolls.
Find the min function. We don't have self.
Oh, I understand. All functions inside of objects have to take it itself. It's the rule of Python. All right, so this guy does the same thing here. Now, we could, in this case, take out list as a parameter, though. Why don't I need to know, since I've moved min inside of the object, why don't I need to know about the list anymore?
You're passing the other list to it using self.
Well, I'm saying if I take list off there, and then I don't pass a list here, because it's not expecting one anymore. What should my list be called in here? Instead of LST, what's the self.recent rolls? So because I'm inside the object, this guy already knows about the list of rolls. So it's no longer called list. Now it's self.recent rolls, which is a synonym for what we had for list before. It would pass in the pointer the memory address of that. All right, we see this guy still runs, does the same thing. What decision do we make to decide whether the function min should be inside of dice collection or outside of dice collection? Go ahead.
If it needs to be accessible by other classes or functions, classes, then or files, even, then put it outside. If not, you should keep everything private.
That's a pretty generic type answer. I'm thinking more of how we solve problems as humans. Does a dice collection need to know what the minimum dice roll is? The answer is maybe. If we decide that one of the abilities of our dice collection is to give us the minimum value, then it should be an ability that we build into the dice collection. Because now I can go in here, and let's assume I'm not going to remove worst. Let's instead say I want to go ahead and I'm going to print out print dice collection dot min. That guy's going to give me the smallest value in the dice collection. I might want to know that. That might be something that's handy for me to, the giant fireball, you drop it, and you look, what's the smallest value? Looking through there. That might make sense for us, in which case we should give that ability to a dice collection. All right, so we'll see this. So now we're able to use, there's that smallest value, the 1. So now we're able to use one of those, that function that we are using in one of our other functions, but now we're using that function directly because it might make sense. Right? Maybe instead of min, we call it smallest roll or something like that if you want to be a little more descriptive. Now, on the other hand, let's just presume that the single smallest roll is not something we'd ever want. In that particular case, we wouldn't want to put it inside of this guy, probably, because it no longer makes sense for an ability of this function or of this object. Okay, so I think for us right now, a good rule of thumb is if a function is something that one of the objects we're writing should be able to do itself, then include it in the object. If instead it's a helper function to allow us to accomplish some sort of complex task, then maybe write it outside of it. The truth is actually maybe a little bit more in the middle. Finding the minimum value in a list is something that has to do with things that goes way beyond a collection of dice, correct? If I have a list of numbers, finding the smallest value in that list of numbers could be handy. Make sense? Okay, so from that perspective, when we have our function inside of here, now we're in a situation where we can no longer utilize that logic that we wrote for other problems outside of dice collection without first creating a dice collection and then forcing our, like, look, I have a list of 300 numbers. It happened to not be dice rolls, but I'm going to go ahead and set this dice collection's recent rolls equal to this guy and then ask it what the minimum value is. It's kind of like a hack, right? I no longer have that tool. The tool is, it was, as we have it written right now, is only made for dice collections. If it's something that could be used more generically, we wouldn't want it to have it as part of a dice collection. At home, you have Scotch tape, or you have some kind of tape. You apply that to lots and lots and lots of different problems, right? You probably wouldn't want to have one of the elements that you might use Scotch tape with to come with its own Scotch tape built into it, and that was your only source of Scotch tape.
I did not get that.
Let's assume that you could not buy Scotch tape at the store. All right? Instead, the blender that's in your kitchen, for one reason or another, happened to come with its own Scotch tape dispenser built into it. Okay? Now, every single time you need to use Scotch tape, you got to go grab the blender. Okay? Bring it to the room because that's how you get your Scotch tape. It came with the blender. That make sense? Okay. That's not something that would make a lot of sense in real life, but that's the only way we can get Scotch tape. Then we drag the blender around the house. It's like, look, where's the Scotch tape? Well, I think Dad's making smoothies right now, so I'm gonna have to wait a few minutes. It's like, I think the blender's in the dishwasher. I don't know, they're not dishwasher safe, but whatever. Get the point? Probably wouldn't want the Scotch tape to only come with blenders. Okay. Not that it even makes sense to come with a blender. That should be actually something we invent. The blender that comes with its own Scotch tape dispenser. I mean, because that actually doesn't make any worse sense than some of these Internet of Things appliances. Like a toaster that can play the radio or something, or a toaster that has that texts you and maybe that makes sense. I don't know. Like, why does your toaster need to be connected to the internet?
Yeah.
Good question. Wait, has he had that?
Oh yeah. I mean, that's the whole. If you've ever seen the synonym or the acronym IoT. There's I guess in technology we have this thing IoT. This is Internet of Things, is what it stands for. So the concept is, hey, we could take any of our things and connect it to the internet. You could take toasters, bars of soap, water bottles. You know, like you have the bottle in your hand, yet it's an Internet of Things, so it actually texts you when it's less than 20% full. I mean, you can look at it. Like, this thing is getting kind of empty. No, I'm going to wait till I get the text.
Time to drink.
Well, I mean, they do that with, like, the Apple Watch. It was, like, time to stand. What if that was, like, built in, like, you know, they had, like, some sort of, like, sensor in your head where it was, like, painful if you didn't stand? And they're all synced, so, like, everybody in class, like, their watch goes off and just everybody stands up just randomly. Like, sit down! You got that one guy who's just fighting it. All right. So if we were creating a toaster object in code, and a blender object in code, it might have that function called blend, and we might feed that function a list of things we wanted to blend. That's kind of the real life equivalent of a blender, right? Okay. We probably wouldn't put the dispense scotch tape function inside of it. Right? That would be something which should live outside of your blender object, because we might want to use that for other things. In fact, we may never want to use that for our blender. You know, if the little Sharpie thing inside of it that spins really, really fast, if that starts getting loose, Scotch tape isn't the tool. Get a new blender. Especially for those people who make smoothies with the lid off. Yeah, you don't want that thing held on by Scotch tape.
You have to buy a new blender every time you run out.
You run out of Scotch tape, you need a new blender. They probably sell refill cartridges. But it'd be a very proprietary thing. You know, they'll charge you an arm and a leg for this thing. It'd be just like Kohler chocolates. It's the Kohler chocolate problem all over again. All right. So, does that make some sense? Now, there isn't necessarily a absolutely right or an absolutely wrong way of solving that problem, of thinking about where does this function live? Does this function live in my object or outside of my object? Okay, because like we just pointed out, some idiot put the internet on a toaster, whether we need it or not. We could put a Scotch tape dispenser on a blender. Maybe it makes a lot of sense for people like the tiny home people. Look, I don't have a drawer for my Scotch tape. I live in a tiny home. It's got to come with one of my appliances. Why not the blender? Okay. We can twist this and make it make sense in some weird, messed up world. Well, you've seen these tiny home shows, right?
Yeah. Tiny house owners.
Yeah, I mean, it's kind of a neat concept. I think especially with VR. Because, you know, with tiny homes, obviously you're not putting a 65-inch TV in a tiny home. A, it won't fit through the door, and B, it won't fit in the house. Okay? But with VR, you can watch you can watch Netflix on a 100-foot screen while sitting in a broom closet or in a tiny home. Right? Because you don't need the physical screen. You have all your spatial stuff inside of VR. It would be perfect. I mean, how many of our houses do we have large percentage of them dedicated to stuff? Do we have a whole room for home entertainment? Now all of a sudden you can just think of your house from the perspective of, okay, what are the absolute requirements that cannot be replaced by technology? Right? Like food, a bed, okay? Toilets, a shower, so you have you can get it down to that minimalistic list of things that have to be in the tiny home. And then everything else can be replaced with technology.
You could have a studio apartment and have it feel like a mansion.
Absolutely. Yeah. I mean, that will be a thing in the next decade. This whole tiny home thing is already kind of a thing, but usually you're making drastic trade-offs. For you're basically saying, look, I won't have a big screen TV. It's not a thing for me. Okay, well, now you could have an unlimited size TV. The only thing is, like, how far are you planning on sitting away from it? Because when you're in VR and you like put one of these screens up, you can make the screen as big as you want it. But if you're sitting right in front of it, then see the upper corner. You got to go like that. But if you go back 100 yards, right? Yeah, I mean, you could have the TV be 4,000 feet because I'm 100 yards away. Okay, or you could move, 10 feet away and make the TV a lot physically smaller and have the exact same visual perception because you're closer to it, and that changes what you can see in your. That's why at the movie theaters I always sit in the second row in the center, because when you recline, your visual field takes you edge to edge to the screen. You're getting the full big screen effect. Any farther back than that, you're seeing curtains and stuff on the side. I mean, that's not efficient. It's not an efficient use of the big screen. Why are you paying to go see something on the big screen if you're not going to use the entirety of the big screen? They got to put the internet in those seats, so they kind of buzz you away from them when you're not in an efficient, like an optimal. All right, so Bible homework's already up. On Wednesday, we'll come back and we're going to now start applying our dice roller stuff to kind of a bigger problem. We're going to have some guys, like some people fighting each other, and we're going to put them in a dungeon and have them moving around and all sorts of stuff like that. So we're going to bring more objects into our solution. All right, I'll see everybody on Wednesday.